Hi, this is part 2 of the video on mastering basic facts. In part 1 we looked at learning trajectory and how students develop ideas of the basic facts over a certain trajectory for each operation. In this video we look at some strategies and some do's and don'ts to help them master basic facts. One strategy is to ask students to memorize facts. Just keep drilling them until they have them all memorized. The problem with that strategy? It starts at the wrong end of the trajectory. It starts here. We want to start here with students and let them build up understanding of the basic facts to support their memorization. Another way is to use explicit strategy instructions. So that is to pick one of these strategies and to tell kids, okay, we're going to learn how to count on from larger and explain what that means and give them problems to try it. The issue with that is that students don't tend to own it for themselves. It hasn't come from their own minds. They might not make sense of it. It might be too easy for them. It might be too hard. So a recommended strategy is to use guided invention. What's this? This is when you give problems to students that they can access at their own place on the trajectory and build understanding and hopefully move up the trajectory as they continue to practice. So for example, give them rich story problems they can make sense of. Then students at all levels of the trajectory can work where they're at. And then when you combine it with discussion of student strategies, so you let the students who are using some of these reasoning properties share that with the students who are counting, and they start realizing, oh, I don't need to count all the time. I can use some of these things for myself. It can be a really powerful way to help students master basic facts and move up that trajectory. You want to group facts together in meaningful ways. So we don't want to just say, okay, today we're going to memorize all the ones with 4s in it. We want to group facts into ways that make sense. For example, all the facts that are +1, because students can start to see this property come out as they work with these +1 facts. Facts with 0s and 1s, you want to group those together and help students think about those. In any operation, 0s and 1s tend to do unique things, so helping them understand why and learn those is good. Using 5 and 10 as anchors and using 10 frames and 5 frames, very powerful way for students to learn the basic facts. For example, kids can start thinking like this redistributed idea, 7 plus 5. Well, that's really 7 plus 3 to get me 10, and then 2 more to give me 12. That can be a powerful way of anchoring on that 10. Doubles. Students can use doubles to do a lot of fact derivations, and so thinking about each of the doubles facts can be a helpful thing. Thinking of subtraction as addition is a powerful thing for students. So if I want to know what 7 minus 4 is, I ask myself 4 plus 3, 4 plus what is 7? Oh, it's plus 3, so my answer is 3. Same kind of thing for division and multiplication. 24 divided by 8 is what? Well, 8 times 3 is 24, so that's my answer. Those are powerful ways to think about those operations. Skip counting is another great basis for multiplication and division. Just practicing skip counting with kids, 3, 6, 9, 12, etc. The more they do that, the better off they're going to have a foundation for multiplication and division. Some of the things you should do with students as you work on mastering basic facts. Make sure they're monitoring themselves. They're always asking, did I do this right? Why did I do this right? Does this make sense? How am I doing? Those are important things for kids to think about instead of just blindly trying numbers and hoping they're right. Focusing on improving themselves rather than comparing to others. Drilling in short time segments. Don't spend long time periods on these things, but work on them over time. Spread out your practice over days and weeks and months. Involving families and getting families at home to help with mastery of these facts can be good. And always trying to make the drill enjoyable. Something they like doing is going to help support them mastering them. Don't use lengthy time tests or public comparisons of who's doing best with these. Don't proceed from 0 to 9. Instead, group those facts in meaningful ways. Don't try to push kids to memorization too soon. They need to have this underpinning to help support that memorization. And don't use basic facts as a barrier to good mathematics. If they don't have their basic facts down yet, let them do good, rich problems and keep working on mastering those facts over time.